Start the recording. Okay, good morning. Today is July 22nd, okay? And since we assign you a work which includes some programming, very simple programming, today I would like you to help you to remember, because I'm sure you studied all of these things, okay? So just to help you, to give you a kick, so you can start doing the homework right away. Okay, so for about half an hour or a bit more than that, Andy is going to help you with that. Okay, so he's going to remind you where you can download the Python system or package, and then just a quick reminder of with a simple example. Okay, how can we implement this? Okay, and then in the second part, I would like you to be sure that everybody understands what information, okay, what experimental information you have to analyze. Okay, so let's see how the groups are formed, so everybody knows what information he or she has to analyze. Okay, okay, Andy, go on.
Okay, doctor. Please, Daniela. Thank you. Wait a moment. Yes. Can you project in full screen? Yeah. Okay. Good morning, everyone. The purpose of this presentation is to help you remember some Python language process that you already studied in the previous courses. So next, please. In previous courses, each of you has already studied how to use the Python language. So now in shape structure, you should easily be able to make diagrams or flow charts to then develop of the codes and solve the problems that would be complicated manually.
Andy, just a second, please. Just a second. Please tell the students in the other room to keep quiet, because otherwise they will interrupt us. Okay, so tell them that I'm asking to keep quiet, please. Otherwise, I heard some interruptions.
Okay, wait a second. Okay.
Okay.
So in previous courses, each of you has already shown how to use the Python language. So now you should be able to make a code, basically. The idea is to give a hard word to the computer, not to us. This is the agenda for today. For this presentation, we will talk about in general for the flow charts, the libraries, variables, algorithms, cycles, and the functions. Next, please. We have some reference to explain the use of the language in a very simple way. It is mentioned that the flowchart is basically a diagram that describes a process, a logical order to develop a task. Next, please. There are different online platforms that allow you create a flow chart in a simple way. This is an example. As you remember, the shape represents something different, so it's not similar for each shape. Next, please. In case you don't have installed in your computer, you can download in the official page. So this is the page you can download. Next, please. There are different environments, some better than others, but the essence is the same. You can use Jupyter or Python. It's not important. Next, please. On the other hand, libraries are set as function that already implement that are available for us to use. For example, to use the cosine function, you must use the math library. We have some different libraries. In the slide, you can see the common library that we need. Basically, is the math and matplotlib to have a graph. Next, please. Remember that there are basic structures such as integers, decimals, and strings. And this is the way that we can assign the value for a variable. Next, please. Conditionals algorithms are set to develop a task. I could enter information, process it with the algorithm, and receive another information. Next, please. Conditionals and cycles help us to decide which process to be developed when a certain conditions are met. You have to be careful when you define that, because we can create infinite cycles and the program will never end. Yes, please. This is a basic flow chart. For example, here we need to calculate the minimum clearance for the propeller. We start with calculating these clearances to have the diameter of the propeller. Calculate using another formula the revolution of the propeller to have the ratio between that to select the gearbox in the local market. This is just an example. Next, please. So functions are very useful when we need a shortcut. Sometimes so as not to write that file code, we can define that process in a function and only call it to use this part of the code. Next, please. So this is the problem that we are going to show the process in a very simple way. This is a real example of work or homeworks. So if you can help me to read, please, someone. For example, Benavides, can you read, please?
Good morning. Well, prepare a flow chart to implement the bisection and Newton Raphs methods to find roots of nonlinear functions. Then implement them using Python programming language and prepare a plot of the friction coefficient FD for road surfaces. Consider adequate range for Reynolds number and roughness ratio. And then is the formula.
Okay, so this is the formula that we need to find the root. As you can see, it's not easy to do that manually, so we need to implement a code in Python. We are going to use the bisection method. As you remember, we start it in mathematical advanced, maybe. So this is the flow chart to solve this problem. In the next slide, we have basically the code. Here we can see that we have two loops or four. So we are going to iterate in two different lists. Okay, next. So first we need to here in the code, yeah. First, we need to import the library. As mentioned before, we need the math for the functions, typical functions that we need, and the library matplotlib to plot the results. So then a list is created with our base information that mentioned in the assignment. So an empty list where we will store our results to graph. Then, as we need to evaluate all the radius we wrote about, we create a loop to go through its radius. Then another for loop is defined to go through the Reynolds number. Until then, with the first four, the first value of the list of the radius or roughness is chosen, and that remains constant until the second four finishes, making its loop. So the Reynolds number will be vary with the value of the constant roughness radius. When the second four finishes its loop, the fifth four chooses the number from the list and repeats it everything. Then we will use a bisection method. Also, we need to define the variables A and B. The tolerance is important that we will be accept, and also the function on which it will be iterated. Then it's basically to apply the bisection method to find the root. You know about this method, so you can implement that. Finally, when the coefficient of friction is found, this value and the Reynolds number are saved in the list that we created in the beginning. So next, at the end, some code to graph our results. You can edit the title, the layer of the graphs, and other parameters. So we are going to have in the next slide our result. This is something that we have after run the program. I don't know if Daniela can run the program to see.
Okay.
And this is for us. This is the code you can use. We are using Python maybe.
Python.
Okay. Yes, this is that we have at the end. You can do it in a 2D case and also in 3D case. It's not difficult. You can program that. And this is what for me also. It's a real example.
It looks easy.
Yes,
but I think the main thing here, the main message here is that it's always recommended that you prepare a flow chart before doing the coding, because otherwise it's easy to get confused. Another thing that you could see in the code that Andy presented is that include comments. See, you're going to do this, you're going to do that, you're going to do that. So you can, if something happens, for example, you can plot partial results. Okay, so you saw this is at the end of this part, this is at the end of that part. So when you see on the screen, you can see where the problem is located. Okay, so those are things that recommendations that you listen, but sometimes you forget it. Something else, okay? It is necessary that in the code that you present for the assignment, you need to include at least your name, date, the number or the name of the class, the assignment. Okay, this is, in this case, for example, it's about bending plate theory. And then in the code, you have to include comments, right? For example, here I'm going to start this, here I'm going to start that. The name, this variable means that, this variable means that, something like that. So that's a proof that you are the one who prepared this program, okay? And eventually, if you want to use later this program, you can see, okay, with explanations, and then automatically you can go and see what's wrong or how can you improve it, okay? Thank you very much, Andy and Daniela. Is there any questions about these people? Is there any questions about this programming? No? Can I ask, for example,
Doctor.
Yeah, there's a question?
When the part is the definition function, it's necessary to include the code and the code programming.
Yeah, everything has to be included. I don't expect the code to be very long. I don't expect. So if you need to include the program and also the functions, yes, that's included. Okay, and for example, in the function, you should include the name of the function as a comment. And what does this function do? Okay.
Doctor, and also students can plot the formula using the video that we posted in our tutorial, so it's not difficult.
Yeah, that's an extremely advantage of this computer language, okay? I usually do not use Python. I usually use Visual Fortran for my programming. And the problem is that at the end, I don't have how to plot. So what I have to do is I have to print all my results in a certain format. And then I have to open either with Excel or EasyPlot or something like that. So in this case, you don't have this problem. You calculate, and then simply with these libraries, you can prepare a plot right away. So it's really a big advantage. Okay, and you can even the possibility of drawing in 2 and also in 3D, which is very nice. Okay, let me ask some people here, how are they doing? Mr. Vasquez, have you started the programming? Mr. Vasquez, have you started the programming?
No, yet. I have some process in paper over the paper, and
Okay.
I'm gonna put in my pie chart.
Okay. Mr. Ramirez, good morning. Are you there?
Yes, doctor.
Have you started the programming?
No, doctor.
No? When are you planning to start the programming?
In this period.
Okay, during this weekend, good. Okay, do you know how to download the Python language? Do you know how to do it? How to download the Python? Please raise your hands, those who know how to download it right now. Okay. Okay, good. Mr. Llanos, you don't know how to download it? You know where you can find the package, the Python package?
Yes. I have the package of Python. Yeah.
Okay,
Yesterday.
so you download it. Good.
Yes. Yes.
Good. I'm glad. Mr. Paredes, Daniel Paredes, do you know how to download it?
Good morning, doctor. Yes, I already download. Yes, but I had any trouble because when I started the programmation, the Python, I was use PyCharm, but in PyCharm I can use the NumPy library.
Okay.
Right now, I am using the another patch for that.
Okay.
It's calling Anaconda.
Okay. Yeah.
And yes, in that I can use the NumPy library.
Okay. Good. Good. Somebody else, Mr. Mendez, Eitel Mendez, did you already download the package? Mr. Mendez? Mr. Mendez, can you hear me? Mr. Mendez? No, Mr. Mendez is not here. Miss Leon, Caroline Leon, can you hear me?
Yes, good morning, doctor.
Good morning. Did you download the Python package?
Yes, I have the download.
Okay, so, okay, people, if you have problems downloading, no, you don't know how, you don't remember what it is, send an email to Andy Miranda or Daniela Sayo. They can help you, okay? Don't, see, usually from time to time, for example, I have to do some programming, right? And usually in my mind, for example, I said, okay, I'm going to spend 2 hours to prepare that program, okay? And usually, the real time that I have to spend is double, it's twice the time at the beginning I suspected I would use, okay? Usually. I know you are smarter than me, I know, but please don't leave for the last minute. Usually there are some problems in the code. It's there, but you don't see it, but it takes time to find the errors. So please try to start right away. Okay, now, what are we going to analyze? Okay, so for this, this is what we're going to do. In the case of the clamped plates, okay, the information is already for you, okay? And Misayo will post this information in the, Misayo, where are you going to post it? In the Teams or in the Aula Virtual?
In Teams, I believe.
Okay, so in Teams, you can find the information, okay? Now, I'm going to show what you have available. Well, I have it in my computer because I downloaded. So let me see.
I send using email to the information, but I want to resend the information.
Yeah. I would say that in a minute. Right now, it's okay. Let me play bending. Yeah. Okay. Let me share the screen now. Okay, can you see my Excel?
Yes, doctor, we can see.
Okay, so this is the information that Misayo prepared for you. Okay, so here you have the weights that were applied in the case of group 10, 8, 3. And here you have the weights that were applied from groups 4 and 6. Okay, and this is the way they were applied. Okay, these are the positions, okay, X and Y, where you have applied all of these weights. Okay, here they are, okay, graphically. So you have all the information, okay. The only thing that we are missing is the thickness, okay. Andy, you are in the lab. After closing this session, we have to measure the thickness. It's probably.
I have the information, but forgot to send that.
Yeah, I think it's 3 millimeters, right? Because that's that plate was employed when we did the test with engineer Ahila some 6 years ago. Okay, so that's the information. What else do you have? You're gonna see that. Let me see if I can open one of these tests. Okay, let me see if I can. There. Base, comma. Shoot. Zip. Here it is. Change that. There. I'm going to show you what you're going to see. Okay, can you see the results?
Yes, we see the easy code.
Okay, so this is the information that you are going to see. Okay, so in the x-axis, this is time, and in the vertical, you have the strain at the different positions. So you have 4 values, right? So some of these are positive, some of these are negative. And these jumps, of course, means that here, this is the original situation. Then you apply this force, then you apply a new one, then you unload and you get back to 0. So what we can do is, for example, let's suppose that I want this area. I want to know the mean value for this, okay? So in the case, the program that I use is EasyPlot. What I can do is take something like this, okay? And after I select this area, I can make an average and calculate the average, okay? For example, I can curve fit this and put polynomial of order 0. Okay, and you see here, this is the value that, okay, so the mean value in this case is 6.9 e to the minus 5. So remember, this is strains, okay? You multiply by 10 to the 6, and that will give you micro strain. So that would represent 69. Okay, so that means that this is the strain that you measure in this point when you apply the maximum load. Okay, then you have to do something similar for each one of these steps. This value here should be equal to this one here. Okay, we have to be careful because they should be. They are not going to be exactly the same. Okay, they're going to be close, but it's not exactly the same. You see here that on the right and on the left, they are very close. That means that the test was really good because they're supposed to be exactly the same. Similar here, on the right and on the left, they are very close. Okay, but it's not exactly the same. Now,
Doctor, I have a question.
Yeah, go on.
What is the date to present this homework of lab?
I think it was already in the system.
Okay, okay.
I'm going to check it. Okay. Now, we see that these tests were developed by group 10, 8, 3, 4, and 6, right? But we're missing some groups, okay? So this is what we're going to be doing. This information, okay, tests from group 3, okay? Since we have this was not developed by group 1, group 1 is also going to analyze these results, okay? This information is also going to be analyzed by group 2, this 3, and this is also going to be analyzed by group 5, okay? By group 7, by group 8, and then we have to go up here. Oh no, group 8 is already here, so this is group 9.
Doctor,
yeah,
we did it and sent the specific information for each group.
Oh, you did already?
Yeah.
Okay, so that's okay. Okay, now the other thing is this, people. Unfortunately, there was a problem with the information that we obtained in the test with the simply supported plate. Okay, so Andy had to do it again. Okay, so he will send you the information. So he will tell you the plate, where the force was located, and the values that he had to apply. Okay, and for each one of these values of the force, he will give you the variation of the strains in the 4 points. Okay, not everybody has the same results. Okay, because we changed the position where you apply the force. Okay, so according to your group, you have to analyze the results, or you have to compare theory and experiments of the result that Andy will send it to you. Okay, similar with the other case, but this information is not the one that you obtain in the test, because we have this problem. I see that, is there any questions about this? Mr. Jimenez, do you have any questions? Or?
Doctor, good morning.
Yeah.
I have a question.
Yeah, go on.
We have the first 10 seconds, right, is or 0 on the data. We have a value. We need to rest this value for the other measures, because this is like a correction, right?
Yeah, yeah. The problem is this, okay? Let me try to draw something here. It's always a problem when we do tests, okay? The problem is that what is the 0? And that's something we should always do. Get the reference value. Okay, can you see my white screen?
Yes, doctor.
Okay, so we have our plate, we have load, and let's suppose we apply 3 weights, okay? This is time, and this is the value of one of the measurements. Okay, so usually the first one, since we just 0 the equipment, we're gonna go like this, very close to 0. And then we go to this, to that. So we have 2, we have this, we go down, and it's possible that we get something like this. Okay, so this is what you have to report. Okay, so you average here, here, and here. And then we plot. This is the force that we apply. and this is the values that we obtain. The first one, of course, is 0, or very close to 0. Then we go this one here, this one here, this one here, and then we go down. So this value, we expect to be close to that, but it's not the same. So the next one is about here. And in this case, we have a negative value like that. Those are the results. What we can do now is we can set a straight line, a regression, like this. So this is going to be your experimental results. So yeah, this is never 0, but it's always a good idea that you try to check if you came back to the original value. The original value was very close to 0. In this case, if you have a large value here, probably there are some problems in the test. So basically, you do not accept this value. What you have to do is you check and try to find out what's wrong, correct the problem, and then do the test again. Miss, I don't know who was the person who was.
Jurado, doctor.
Okay. Jurado, did I answer your concern, Jurado?
Yes, thank you.
Okay, no problem. Anybody else, people? Anybody else? Any other questions about this?
Yes, doctor, what we should include in the report? Just the deflection, the normal stress, the shear stress, and nothing else?
What can you compare?
With the theory, obviously.
Yeah, what can you compare with the theory?
The deflection, the
No,
normal
you
stress.
did not measure the deflection. What did you measure in the test? You only measure 4 values of strains, right?
Yes.
So
yes.
all what you can do is you can compare strains at these 4 values. That's all what you can do.
Just compare the strains with the theory.
Yeah, that's all what you can do because you measure only strains at 4 positions. So that's all what you can compare.
Okay.
You did not measure deflection. See, in some cases, okay, we can install here, for example, a device to measure the deflection, okay, the W, but we did not have this device. So only we measure strains here, here, and at the central point. Okay, so if you plot, okay, 8 curves in the same graph, it's going to be messy, right? So what you can do is you can plot, for example, the result from the X directions and the results from the Y directions. In that case, you will have 4 curves in each plot. So here, for example, you're going to have EX1 and EX2. And in the other, you can plot EY1 and EY2 versus force. Some of these will be positives in the case of the clamped. Some of these are going to be negative. Okay, so we have to be careful with that. Okay. Any other question, people? So here, what you'd have to do is you have to plot, calculate and plot the theoretical values, and hopefully they will be close to those. Okay, so you're going to have, suppose like this. So this is theory. So these 2 curves are, for example, for EX1. So you have something similar for the EX2 and then for EY1 and EY2. People, is there any question? Is there any other question? No? Okay, finally, I want you to see, in the case of the simply supported plate, okay, in that case, each one of you okay, will solve this problem. Each one of you analyze the simply supported plate with a concentrated force. Okay, what you have to do now is take your program, use the values that from the experiment, specify the position where you apply the force in the experiment, and that will give you the theoretical results. So what you have to do is you have to evaluate the bending moment in the 4 points and the 3 point, or the 4 evaluations where you measure the strengths. With the bending moment, you calculate stresses. With the stresses, you calculate strains, and you can compare. In the case of the clamped plate, okay, you did not solve this, and we are not going to solve this theoretically. So what theory should we apply? Okay, this is what we are going to do. We're going to do a simple computer program that was developed some years ago by an engineer, Rina Ahila. Okay, she graduated some 6 or 7 years ago. She's working at the Astinave. She prepared a program using the finite difference method. Not finite element, but finite difference method. Okay, so I load this program together with an example file, a data file. So you have to take this data file and you have to alter. I'm going to show it to you, okay? See, we have to open first. Where is that? That's in applications. Okay, so let's go now. Okay, can you see my text file?
Yes, doctor.
Okay, so here we are. So we have, this is the data file, it's a text file, so you can open with Notepad. Okay, now, on the right-hand side, on the right of each line, you see some explanation. And that explanation was included by Karina in order to help you to use this program. Okay, so here, for example, you see this is 5.343. This is the plate length in the in the X direction. That's the dimension A. That's dimension B. That's the plate thickness. So you have to replace those by your values. Then you have Young modulus of the plate and of the stiffener. I'm going to say that in a couple of seconds. Okay. In this case, we employed this this program to try to analyze plates with stiffeners. You do not have any stiffener, right? So what you can do is you can replace, for example, here in the thickness, you can take this value equal to 0. Okay, so you replace all the thicknesses, all of these 4 values with 0. So you have something with thickness 0. That's, you don't have it. That's all. Okay. This is effective breadth. Don't worry about that because we don't have stiffeners, so there is no problem for that. But if you want, you can put it in 0 here, and that's it. Okay. Now here, this doesn't make any difference because you don't have stiffeners. Here, this 1111 means that in the top side, right side, lower side, left side, what's the boundary condition of the plate? Okay, so if you put 1 here, each one of these sides can be fixed, simply supported, or free. In your case, you have to put 1 because you have clamped it in all edges, right? This can be used in case you have distributed load, okay? So in this case, you specify the load in each one of the corners. And internally, the program does a linear interpolation. In this case, you have no distributed load. So you set the 4 values equal to 0. And here, you have one concentrated load, one concentrated force, right? So you leave this one, and this is the X position, the Y position, and the value of the force. Okay? Any questions so far? No? So you take this and you change the original values for the values that you have in the test. Okay, so Misayo gave you in the Excel table the length in the X direction, the length in the Y direction, and the thickness is 3 millimeters. You have to be careful because this is not steel, so you have to change these values. Okay, this is aluminum. It's 5083 alloy. So you have to look for in the literature for these 2 values. This has to be 0 because there are no stiffeners. And here you have to include the position where you are applying the load and also the value of the load. You have this data file available in the Aula Virtual. Now, if we want to run it, okay, I'm giving you the program. Let me okay, when you click on the program, can you see the running of my program? Can you see in blue?
Yes, doctor.
Okay, so when you click on the ortho plate, it's an application, okay? In this program, we applied what we call the orthotropic plate theory in order to analyze plate with reinforcements. Okay, but we could analyze this without any problem if we get the stiffness out of the problem. Okay. Now, please read the information. Can you read what it says here? Please, can you read? Ms. Valdez, can you read what you see here in this screen or no?
Okay.
Can you read it?
Please type the number of nodal points in X direction.
Type the number of nodal points. Everybody took the course, the numerical analysis course, and everybody knows the application of the finite differences method. Okay, so you take the plate and you divide it. How many points? You specify the number of points. A decent number of points would be maybe 21 or 25. That's enough. If you want to try it with more points, but you will get more and more information. And now he will ask you something similar for the Y direction. Okay, so let's see, I put it 21, and then he asked me for the Y direction. I put it 21 again, and then he will ask you for the name of the data file. Name of the data file. Now, in this case, the name is, okay, let's see if I can. It's a very long name, that's the problem. Okay, datos, space modelo, space 3 dash carga concentrada .txt. Where do you want the results to be printed in a file? For example, I could use simply resultados 2022. Okay, he can find the data file. That's the problem. Okay, but that's all what you need to do. Okay, click it on the application. He will ask you how many partitions in the X direction, how many partitions in the Y direction, and then just the name of the data file, and then the name of the result file. Okay, and that's all. So you have that's the situation. For example, let's suppose that I asked for 4 partitions. So I said, I'm going to use 1, 2, 3, and 4 partitions in X. And let's use 3 partitions in Y. So it's going to be 1, 2, and 3. So this is the way he's going to partition the domain. Now, the problem is that when you evaluate the 4 derivative here, you need to evaluate the value of the function here and here. Okay? So what it's going to give you is going to analyze this system of equations with extra lines. Okay? When you see the results, it will give you X, Y, and many properties. Okay? Now, what he's going to show you here are the values inside the domain. But he will move this origin to this origin. Okay? But this is the final situation, right? Like this is like a new X prime and new Y prime. Why? Because the program needs to include these joints to evaluate the 4th derivative when you try to approximate the solution here and here. Okay, it's like moving the plate, but that's all. Okay, and here you will see that there are lots of information, deflection, bending moment, shear force, stresses. Okay, now in this case, for example, if you have, there are not many points here, but for example, if you have more points or partitions, okay, you could identify where is your strain gauge located. For example, here, we have one strain gauge. So this value here, corresponding to this point, will give me the information that I want to compare with the experimental results. Okay? Any problem, people? Any problem?
This program we can use this program for our reports, or?
Yeah, this is, you can use it only for the
simple support
case, for the clamped case.
The program is only for the clamped.
No, you can use it for the simply supported, but no, for the simply supported, you have to use your own computer program.
Okay.
Yeah, in the individual part, you have to prepare a program. You have to use that to compare with the experimental results. For the other case, for the clamped case, okay, you have to use this program in order to apply final differences to get the theoretical results, and those results will be compared with the experimental part. Okay. And if you see any problems with the program, you can send an email to Karina Gila. She works in Asinave. Tell her that we need an explanation because this is not working well. So this is a way that we can check the results of this program.
The program was her thesis or something like this?
Yeah, it's a thesis. Her name is Karina. And she graduated in 2005, in 15, I'm sorry. We did some tests with impact. Okay, we impacted some reinforcements, okay, here in the lab. So we tried to measure how big was the spike. And in that case, we have to include reinforcement in both directions. If you want, yeah, you can find the thesis in the system. So it's in there. Okay, people, if there is no more question, then I'll see you Tuesday morning, okay? If there are problems, send me an email. I'll try to answer as soon as I can. Please, please, I'm begging you, open the Python and start doing the report right away. Okay? Believe me, I have a lot of experience. Every time, okay, I think, okay, this program I do it in 3 hours, forget it. I need 6 hours. If you are thinking that you're going to spend 5 hours for the program, forget it. You're going to use 15. Because you are not used to programming. Because you did that maybe 1 or 2 years ago, right? So if there is an error in the code, probably it will take you more time to detect the error. So please start right away. Okay, have a nice weekend, and I'll see you Tuesday.